Alright, so in this video, I'm going to be solving the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So let me first rewrite my equation down here so I have a little more solving space. So my equation is 3 to the power of x plus 3 to the power of x is equal to 12. And the first thing I'm going to do from here is factor out 3 to the power of x from my left-hand side. So I get 3 to the power of x times, 3 to the power of x divided by 3 to the power of x is 1. So 1 plus 1 is equal to 12. And 1 plus 1 is 2. So I get 3 to the power of x times 2 is equal to 12. And now I can divide both sides by 2. So then these two cancel out. And I get 3 to the power of x is equal to 6. Now from here, what I'm going to do is take the log on both sides. So I get log 3 to the power of x is equal to log 6. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 3 to the power of x, so I can move x to the front. So this turns into x times log 3 is equal to log 6. Now from here, I can divide both sides by log 3. So then these two cancel out, and I get x is equal to log 6 over log 3. Now, log 6 is the same thing as log of 3 times 2. And if I have something in the form log a times b, this is equal to log a plus log b. So log 3 times 2 turns into log 3 plus log 2, and I have this over log 3. So now this turns into log 3 over log 3 plus log 2 over log 3. So then these two cancel out, and I get 1 plus log 2 over log 3. So this is my answer. Alright, so in this equation, I'm going to be solving 9 to the power of x is equal to 36. So to start, my variable in this equation is x, which is what I'm going to be solving for. And we can already tell that x is not going to be a whole number, because 9 to the power of 1 is 9, and 9 to the power of 2 is 81. So we know that x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So to do that, what I'm first going to do is take the log on both sides. So I get log 9 to the power of x is equal to log 36. And the reason I used logarithms for this is because they have a special property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. So before, x was an exponent, and it's almost impossible to solve the equation just in the form x is. But now we can move x to the front and make it equal to a whole number, and now it's much easier to solve for x. So now I get x times log 9 is equal to log 36. And now, obviously, we want to isolate x, so I'm going to divide both sides by log 9. So then these two cancel out, and I get x is equal to log 36 over log 9. Now, we aren't done yet because we want to find the exact value of x, so we don't want any logarithms in our solution. So now what I'm going to do is I'm going to rewrite log of 36 as log of 9 times 4 because I just want to simplify log 36. And now I can use the property that states that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, I have log 9 times 4, and we can say that a is 9 and b is 4. So this turns into log of a, which is 9, plus log of b, which is 4. And remember, I still have all of this over log 9. Now, if I have something in the form a plus b over c, this is equal to a over c plus b over c, and this is just using fraction properties. So I have log 9 plus log 4 over log 9, and I'm going to rewrite this as log 9 over log 9 plus log 4 over log 9. Now, anything over itself equals 1, so log 9 and log 9 cancel out, and I get 1 plus log 4 over log 9. Now from here, I'm going to simplify this by rewriting log 4 as log of 2 squared, because 4 is equal to 2 squared. And I'm going to do the same thing to log 9. I'm going to rewrite it as log of 3 squared. So now remember that if I have something in the form log a to the power of b, this is equal to b times log a, because I can move b to the front. So I'm going to be reusing this property on these two terms. So log 2 squared, I'm going to move the 2 to the front. And same with log 3 squared, I'm going to move the 2 to the front. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. And now I can cancel out these 2's. So I get x is equal to 1 plus log 2 over log 3. So now from here, log of 2 is equal to 0.3010, and log of 3 is equal to 0.4771, meaning x is equal to 1 plus 0.301 over 0.4771, which is equal to 0.6309. So 1 plus 0.6309 is 1.6309. So this is my solution.